Actually messed one up. I didn't want to waste your time, so I had to delete it all and starting fresh. I messed this one up when I was solving by hand, and I'm going to do the solve by hand first. Number 6 is the one I was looking at. There's 4 equations. All right. You either have negative x plus 4 minus 2 equals x plus 2 minus 8. There's one of them. Or you have negative x minus 4 minus 2 equals x plus 2 minus 8. Or, see what I've done here is I've swapped those two around. I've written the two things that were inside up here. Or I'm going to leave, I have to think about all the possibilities here. All right, I've swapped those two around. Now I'm going to swap these two around. I'm trying to think if that's actually what I need to do on this one. Seems like the right answer is a mixture of the two, because there's a lot of possibilities here. You can have these pieces be the same. You can have this piece be negated. You can have this piece be negated. And then you can negate this piece. See, that's something you can do. Or you can leave this piece alone and have that, which we've already done. Well, what's the other thing we can do? I can, well, actually, that would probably do it, wouldn't it? That one's positive, that one's positive, that one's positive, that one's negative. That one's negative, that one's negative. I think I've done them all. Okay, I think these are the 3 equations I need. But I'm pretty tired right now. But anyways, let's clean these up. This is negative x minus 4 minus 2, so minus 6, equal to x plus 2 minus 8, which is minus 6. And if we put our x's on one side, we'd have negative 2x equal to 0. We divide by negative 2 and we get 0. There's a possible answer. If we solve this one, we clean it up here, we'd have x plus 4 minus 2. So x plus 4 minus 2 is plus 2. And on the right-hand side, we'd have x minus 6. And when we shift x's this way, we get 0x equals negative 8. And we divide by 0, we get domain. Or sorry, divide by 0. Anyways, it's undefined. There's nothing happening there. Absolutely nothing's happening there. And the last equation I wrote, which is hopefully the last one I need, a negative times a negative is positive, so I have x plus 4 minus 2, so plus 2 equals negative x minus 10. This is the one I need. If I shift that over, I get 2x equals negative 12, and my x value is negative 6. I had to actually sit and think about all the ways I could write the swapping of what's inside absolute value. Those are the 2x values. They're 0 and negative 6. It's actually probably harder to do this particular equation by hand than it is by the graph, which is unusual. It is. It's unusual. All right, back to graphing. We're doing the absolute value of a times x minus h plus k. So this guy is, what just happened? Lost you for a second. There we go. This guy has been shifted left 4 down 2. And it falls 1 and runs 1. Since I already know where the answers are, I'm not going to make as many dots as I usually do. That should do it. All right, that guy is going to be left 2 down 8. And it has a slope of 1, because there's an understood 1 there. And there you go. So you've got this nice ordered pair here that is at 0, -6. Sorry, yeah, 0, -6. There was that 0. Then you've got this other ordered pair that was at -6, comma, looks like -4. And there's that -6. So there's that one. All right, then we have some inequalities. You're supposed to use a graph to solve the inequality and then solve algebraically. I know how kids feel about this, but I mean, it is what it is. It's in the next math class you take too. Solving compound inequalities is in dual enrollment, college algebra 140. Your college path, they keep asking you to do stuff like this. All right, so in order to do this, you're probably going to have to graph it. And this one's kind of ugly. In a degree, it's kind of ugly. Graphing it's not the best thing to do. So what I'm going to do is I'm going to factor this thing. I'm going to factor it as x, looks like -8, x plus 1. And what I want here is I want these zeros. So I'm going to set it equal to 0. It has a 0 at x equals 8 and x equals -1. So in other words, the ordered pair 8, 0 is on the graph and -1, 0 is on the graph. Fair enough. It doesn't have to be a pretty picture. It doesn't. I mean, you can find the vertex. The vertex h is at opposite b over 2a, so 7 over 2 times 1, which is at 3.5. And plugging that in is kind of a pain. But none of that actually matters. It really doesn't, because what they're asking for doesn't mean you need a full picture of the graph. So the vertex is somewhere on this line right here, which we call a line of symmetry. The reason it doesn't matter is because of what they're asking. They're asking where you're greater than 0. In other words, above the x-axis. That's what's being asked. All right? You're above the x-axis here and here. So long as you're less than -1, you're above the x-axis. So long as you're more than 8, you're above the x-axis. So for my graph, I can do something like -infinity to -1, union with 8 to infinity. Or if I love set builder notation, I can say all values of x such that x is less than -1 and x is greater than 8. I can do things like that. Now, solving algebraically is very, very close to how I just did it. I take the thing and I say it's more than 0, and I factor it. That's what I do. I factor the thing. And you were supposed to do this in Algebra 1. I don't know if you did or not. Even solving algebraically, you still have to do something kind of funny. And these are called critical values. Notice there was no equality. It wasn't a thing. There is no equality. And I just kind of plot them. Open hole. Open hole. And then I test. That's what I do. So if I want to know if I can shade left, I'm going to test something left of -1. So I'm going to test a -2. I'm going to take my equation and plug a -2 into it. I know how kids feel about this. I know how kids feel about the multiple steps that we do. But if I crank out the math right here, this is 4 plus 14 minus 8. 4 plus 14 is 18. Take away 8, you get 10. And 10 is greater than 0. That's a true statement. I get to shade everything to the left of that. I'm going to test something in the middle. So I'm going to test a 0 because it's easy. 0 squared minus 7 zeros minus 8 greater than 0. That gives me -8 greater than 0, and that's false. So none of this crap on the interior matters. And then I got to test something to the right of 8, so I'll test 9. So I have 9 squared minus 7 nines minus 8, hoping it's greater than 0. That's 81 minus, oh good Lord, 63, which is 18, and 18 minus 8 is 10. So we have another true statement. And hopefully you can understand that the number line I drew is demonstrating that. H y'all can do, at least I hope you can. I'm going to save 9 and 10 for y'all because you need to practice it. Let's do a technology one. I'll look at 13. It's kind of a hard one to put in. So on these new faceplates, you can put in a fraction. On the old faceplates, you had to type like 1/5 in parentheses. But on new faceplates, you can go to Math and then hit the down arrow or the up arrow one time. Whoops, sorry, you got to go to num first. If you'll scroll all the way down to n/d, you can type in a fraction. So it's 1/5. Those are the absolute value bars. You go to Math, num, ABS, type in your equation. Then we have a -3. I'm putting the second, and I need to write down what I'm doing here. I'm putting the left-hand side into y1, and I'll put the right-hand side into y2. So anyways, Math, num, n/d, 1/8. That is x to the second. Oh, and there was a negative symbol there. Let me insert that. -6x plus 9. And I need to make sure that that's big enough for y'all to see. And then I'm going to hit zoom. 6. There's a v. And there's part of a parabola. Part of it. This is -1/8 x squared. It's opening down. You're seeing the right-hand side of it. So I'm going to play with my window. I'm going to go to x min, and I'm going to change it to about -20 and hit the graph key. See if I can see the other side of my parabola. If not, I'm going to keep playing with the window. And I don't see it. Try -50. I'm looking left. Ah, there she is. So there's two answers here. I'm going to hit second trace 5 for intersect. I'm going to take my cursor and I'm going to get it close to the left-hand intersection. Then I'm going to press enter 3 times. 1, 2, 3. And I've got -48.448 because how did I ask you to round? Fourth decimal. -48.4476. There's one of them. Second trace again, 5 for intersect. Take your little cursor and notice I'm just holding down this right cursor button and I'm going to get it right about there. And when it gets there, I'm going to press enter once, twice, thrice. So enter, enter, enter. 1.8053. That's how hard it is to use a calculator. There are some kids, though, who will go all year and they will never learn how to use the calculator. And they will complain about how hard Algebra 2 was. And I'll see you next year. I'll do 15 for you. I'll save the kickball problem for you. The amount in millions of dollars that a company earns in revenue for selling X items in thousands is revenue as a function of X is -2x squared plus 18x minus 2. The expenses for selling X items is E is 0.25x plus 6. If profit is revenue minus expense, so we can create a profit function. Revenue is -2x squared plus 18x minus 2 minus expense, and there's two things there, 0.25x plus 6. Because there's two things I wrap, I have a function. All right? Write a profit function. We'll clean it up, put it in standard form, 18x plus 0.25x because we distribute, sorry, 18x minus 25 hundredths of x, so plus 17.75x, and then I have negative 2 minus 6 minus 8. There is my profit function. Use technology to determine how many items a company must sell to be profitable. And if you think about what's going to happen here, you should be seeing a graph look something like that because negative 2. So let's take a look at it. Negative 2x to the second plus 18x minus 2. Whoops. Tired. Very tired. 17.75x minus 8. That's the right equation. Zoom 6. So this company is profitable from here to here. All right. You see that? I'm actually going to put a 0 in here because the idea here is that this profit is bigger than 0. So I'm going to put a 0 into y2. The reason I'm doing that is because I can now use the intersect feature. It drew that red line. So second trace 5, get close, enter, enter, enter. And the left value here, and again, this is in thousands, is it not? I got a 0.4763. Go after the right one. Enter, enter, enter. I got 8.3987. Now, I realize some of you are just horrible at math, but 0.4763 times 1,000 is this, 476.3. 476 would still be a loss. If you think about that graph, it would be below the x-axis. So we need 477. We start making money at 477 units, and we stop making money here. So we take our 8.3987, we multiply it by 1,000. And if you round this up, you would actually be below the x-axis, you'd be losing money. So you need to keep it rounded down. 8398. That's what it looks like as an interval. And I should probably be using hard brackets on this. So all values of x such that x is stuck between 477 and 8,398 are profitable. There you go. You do the rest. I've done enough. And I ain't even getting paid yet if you look at the clock. I've done enough.